Hello everyone, sorry if this is disappointing, but there's once again not going to be a problem review in this video today because I don't have enough time and I have school tomorrow. So basically today I grinded for 2 hours and 45 minutes and I was able to finish all 3 problems in this USACO 2018 US Open contest silver. But that's, first of all, that's not impressive because it's 2018. Even though it's US Open in 2018 is like basically I would say January level or December of 2020 or something like that. So this is really easy. All 3 of these problems are really easy. The last one's a bit challenging, but I'll talk about that in a minute. But even with this difficulty, I was not able to fully finish out those because I couldn't understand the problem with the first one because I never actually learned the bubble sort algorithm. So this, I could not understand it pursue the code. Basically, I thought you only swap once every turn, and then I just found the number of inversions. And then I realized it's not nearly as complicated as finding inversions because that will take sorting or binary index tree algorithm, and both of those are gold levels. So it doesn't actually, you don't even need to actually find the number of inversions. In fact, it's just because every element can move left by at most one. So according to the solution, then it's just the element that moved left by the most. Yes, I had to look at the solution even for this problem because I couldn't understand it. So I probably still would have solved it if I didn't look at the solution. It'd take me like a bit longer, but if I understood the problem correctly, I probably could solve it if this was a real contest. But it's 2018, doesn't matter. Second problem now. The second one is limited line. This is probably one of the easiest silver I've seen in a while. Probably even easier than the 2019 January, which I've been saying repeatedly that that's the easiest contest I've seen. This contest is not as easy, but this specific problem is template binary search. Most basic template binary search, and even the check function is like, it's not even greedy. It's just one calculation for the check function, which is really, really bad for silver. It's not supposed to be this easy, but I prefer it to be easy. Third problem. This is actually the interesting one. I was able to solve it fully on myself by myself, but it's actually a pretty hard problem because I didn't actually think my algorithm was correct time wise, because this problem you're supposed to solve it within n cubed complexity, but my algorithm, in the worst case, I thought it was going to be n to the fourth, but somehow it isn't. So basically my algorithm, my implementation is, for each component, if you read the problem already, for each there's going to be a component, a connected component, I will say, of each color, and for each of them I record what other component is the next to, and then we go to those components. So we basically just DFS from the center of every component, but then with the color only that's next to. So we don't DFS every color with every other color, but only every color with a color that is next to in some component of this color, if you understand. And so basically, I tried doing that, but it did not work. And then I thought of shrinking the components into only the border points and skipping, with an arrow quote there, skipping the middle points and only go on the border points, because then I feel like that will reduce the complexity by a little bit. And maybe, because it's 2018, maybe the weak test data would just let me pass. And it didn't let me pass. So I thought it was because the test data was weak. And then I looked at the contest solution, and that was the correct solution. That was exactly what this guy did. That was exactly what the official solution did. So my solution was actually official, but that's not my thinking process at all. What they said is they're shrinking everything. No, not shrinking. They're turning every component to a point and then connecting edges between components. That's not at all what I did. I just recorded kind of like an adjacency list. I just literally what every component is adjacent to. I iterated through all of them, and I used the map to record what colors already been iterated with this component's color. And it's just like, I didn't even actually think of anything. It's just like a programmer's intuitive move. And if you know your algorithm is going to be out of time if you don't optimize it, and you just intuitively optimize it in a few very classical way. Anyways, that's for the problem 3, and I would say it's the only problem out of this contest that's actually a little bit challenging. So that's it for this contest. And now I have one actually question for you guys. It's actually a question because I actually don't know the answer. Because if any of you uses this programming website, which is really good, it's called luogu.com. It's in Chinese, but I'm pretty sure a lot of programmers are Chinese anyways. But actually, I'm just gonna pull this over here. It's for this problem, right? This is a Chinese version of the problem, and even though my program passed on USACO, it could not pass on this online judge. So I have no idea what happened. Okay, I guess Logo's under hacker attack again. This happens once in a while, but it's a good website when it works. And I usually submit all my USACO problems I solved on USACO onto there as well, but today just didn't work. And this is not the first time. A lot of the times, USACO problem that I solve somehow turns out to be runtime error on other OJ, not only this one. So I'm just reaching out for you other better programmers than me on YouTube. So if you could maybe answer me in the comments below, why does USACO not turn out to be runtime error for some programs that are runtime error for other OJs, not just Logu? So yeah, that's it for today's crime report. I'm grinding for 2 hours and 45 minutes. Not good, but that's the best I can do. I have other stuff going on now that school started. But anyways, thank you for watching this today's video. Thank you.